Did you know that renewable energy is already supporting the dual goals of reliable and affordable electricity? These resources are providing new, much-needed, low-cost, fuel-free electricity to support the rising demand for power. For example, in 2024, the amount of battery storage installed in the U.S. doubled. Large U.S. electric grids in Texas and California regularly operate using more than 70% renewable energy. Electric grids in Hawaii, South Australia, and Denmark already operate using 100% renewable power for days at a time. Clean electricity is powering the energy transition by meeting demand from data centers, manufacturing, and the electrification of vehicles, buildings, and industry. It is also replacing older power plants that are ready to come offline. But grid reliability is about more than just keeping the lights on. Grid reliability describes how well the electricity system can meet demand and keep power flowing steadily as conditions change. Clean energy technologies support two key components of grid reliability. Resource adequacy means having enough electricity supply and storage to meet customer demand with sufficient supply, especially during peak periods like hot afternoons and cold mornings. Reliable operation means balancing energy supply and demand in real time to keep the flow of current steady and keep the lights on. Different energy resources provide distinct reliability services. Grid operators rely on these services to maintain the balance of voltage and frequency. A reliable electricity portfolio doesn't need to rely on big, centralized power plants. In fact, no resource is available 100% of the time. For example, solar and wind output vary with weather conditions over the course of the day and year. Large-scale nuclear plants provide consistent power but are difficult to ramp up or down to adjust supply quickly. Gas and coal plants can suffer outages in extreme weather events like winter storms Uri and Elliott, or fuel shortages when coal piles or pipelines freeze. They can also break down during normal operations. A coal plant in Colorado will be offline for nearly a year after a breakdown, and one in Texas will be offline for 2 years after a catastrophic failure in April 2025. Much like a balanced stock portfolio, a diversified grid of complementary resources provides an important hedge against risks and helps the system perform under different conditions. Maintaining a reliable grid requires valuing each resource accurately and building a generation portfolio that balances supply and demand. The transition is already underway. Government officials, utility providers, and grid operators can take near-term actions to maintain a reliable electric grid. First, make it easier and faster to permit and connect new power plants and vital transmission infrastructure. Second, utilize grid-enhancing technologies and advanced conductors to increase the capacity of existing transmission lines. This can be done much faster than bringing new generation online. And finally, allow all resources to provide essential reliability services and compensate them fairly for their grid value. The bottom line is simple. A clean grid can be a more reliable grid. A balanced grid made up of renewable energy, batteries, demand-side solutions, and other carbon-free resources can provide reliable and affordable electricity to power our future.